Okay, now we are going to do our simplifying rational expression sheet. So let's get started. Problem number 1 says, let's simplify completely m squared plus 2m plus 1 over 10m minus 10 times 20 over m plus 1. Now, the first step to any simplification problem should be to factor if you can. Because in order to cancel, and simplification always means either canceling stuff out or collecting like terms. So if we're going to get things simplified, we'd like to maybe be able to factor and do some canceling. So let's take a look at that numerator. Oh my goodness, it's one of our quadratic trinomials. So we're going to factor it into 2 parentheses using our reverse FOIL logic. And it looks like we're going to end up with, okay, an m plus 1 plus 1. Now again, if that's confusing to you, think about unfoiling it, because that's what we're doing. If you FOIL these together, you would get m squared plus m plus m plus 1, which is m squared plus 2m plus 1. So when you have this, think about that foiling in reverse, and this is what you would generate. Now on the bottom, it's way simpler than that. There really isn't anything to do on the bottom except take out your GCF. Your greatest common factor is 10, so we'll pull out a 10 and we'll be left with 10 times m minus 1. And that still times the 20 over m plus 1. Now, how do we multiply fractions? Well, think about it for a minute. Think about 2/3 times 4/7. How do you multiply those two fractions together? You multiply the top times the top and the bottom times the bottom. That's exactly what we're going to do here. So I'm going to multiply 20 times m plus 1, m plus 1, over 10 times m minus 1, m plus 1. I simply multiply everything on the top times everything on the top and everything on the bottom. Now you might be saying, Mrs. Ford, why did you put the 20 out in front? Why did you move the 20 out there? Well, a couple of reasons. First of all, multiplication is commutative. So the order of the multiplication doesn't matter. You know that. 2 times 3 is 3 times 2. Generally speaking, when we have complicated expressions like this, we like to have the coefficient in front, the leading coefficient, the coefficient in front. So I always write them out there. Most people do. Kind of get in the habit of that if you can. Now, everything is factored. I am allowed to start canceling. Now, again, keep in mind, back here, I had m's over m's. I could not cancel at this point because you are never allowed to cancel unless you factor first. So I'm all factored. So now I am allowed to cancel whole factors, not pieces of factors. You're not going to see me cancel this m and this m. I have to cancel the whole factor. So these two match, so out they go. Furthermore, I have 20 over 10. That reduces to 2 over 1. So my answer becomes 2 times m plus 1 over m minus 1. Perfect. Let's look at the next one. Uh-oh. Look at the next one. It looks a little bit different because it is not a multiplication problem like this one was. This was a multiply. This one is a division problem. So now I'm going to ask you to go back. What do you remember about dividing fractions? How did you handle the division of fractions? Well, hopefully you remember that when you divide fractions, you multiply by the reciprocal of the second one. We call it inverting and multiplying, flipping it over and multiplying. So 2/3 divided by 4/7 would be 2/3 times 7/4. Same thing. A little bit bigger problem, but same idea. So x plus 3 over 8 times 24 over x squared minus 9. Now we have a problem exactly like the one we just did. The difference is we had this extra step. We made it a multiplication problem. But now we're going to proceed exactly the same. So what do we do first? Don't you dare start canceling. Before you start canceling, let's get it factored. So x plus 3 over 8 is pretty much done. What happens here? We got 24 over, what's that? That's one of our difference of squares. And when we factor the difference of squares, it's x minus 3, x plus 3. It's the square root plus the square root and the square root minus the square root always. So now we can multiply, putting my coefficient out in front. And remember, you're allowed to cancel, but only whole factors. So x plus 3, gone. And 8 goes into 24 3 times. So on the top, we have a 3. And on the bottom, all we have left is our x minus 3. There's your answer. Pretty simple. All right, let's look at number 3. It does indeed look a little scary. Please do not be afraid. You will manage this very readily. Because this is nothing more than a division problem. But instead of being written sideways, it's written up and down. This is exactly the same as 2 over x minus 4 divided by 6 over x squared minus 5x plus 4. This is a division bar. So it's this fraction divided by this fraction. Well, we just talked about it. When you have a division of fractions, you turn the second one over and multiply. Now, what do we do next? Well, you know exactly what to do next. You're going to want to start canceling, but you can't do any canceling until you get the thing factored. So we've got 2 over x minus 4. Now, what about this guy? Well, he's another one of our trinomials. So we're going to think about unfoiling it, undistributing it. So we're going to have an x and an x. Now I'm thinking ahead. With a 4 on the end, I've got choices. I can use 2 and 2 or 4 and 1. Remember, I want to generate a 5 in the middle. These are going to have to be minuses because whatever I put here has to multiply to give me a positive number, but add up to be a negative number. So what would be the best choice? If you're saying 4 and 1, you are exactly right. Because when you FOIL that out, you're going to get a minus 1x, and a minus 4x. That's how you're going to get that minus 5. Perfect. Now I can put it all together. And then whole factors will cancel. So the x minus 4s are gone. 2 goes into 6 3 times. So on the top, all that's left is x minus 1, and on the bottom, all that's left, I guess, is my 3. So there's the answer to the question. Good job.